All right. The next little tip, trick, topic here is the elliptical, helix, or spiral. And it doesn't have to be an ellipse or a helix. Take a magazine from a pistol, for example. We have a couple of our customers, such as Remington Arms and MD Arms, out there that might need this type of interaction here, where they get an elliptical helix, right, for a spring inside the magazine. Okay, but how do you get that? You can't project it. You can't wrap it. You can't split line it. Okay, so there's literally some steps that you can take here to get a helix that runs along an elliptical shape like that. Actually, it's quite handy. So here's your answer. It's called an intersection curve. Okay, is the tool that we're going to use. And I'm going to go through these steps here. You don't have to read them, but they're here on the slide for you so that you can come back to them and look at them later. Okay, but I'm going to come back over here to SolidWorks and start a new part. Okay, and what I'm going to do is I'm going to start on the top plane. I'm just going to start a sketch. And I'm bumping my S key here on the screen, by the way. I hope you guys are all taking advantage of the new little tips and tricks that come out, in SolidWorks each year. This came out in about 2010. It's the S key on your keyboard, which is quite handy. It's the context-sensitive menu that pops up anywhere your cursor is as you hit the S key. Now, if you hit it twice, new for 2012, you'll see up in the upper right-hand corner here it goes to the search command, which is a new feature here. Okay, but I'm going to bump my S key and grab my ellipse tool, okay, which is quite handy on there. I'm just going to come out here and just draw myself an ellipse and dimension this thing into place so that we have some parameters to go on here. We'll go 50 that way. And of course, with an ellipse, you can't just do the center, the major and minor sizes here. You have to also lock this guy in, horizontal or vertical, in that regard to make it fully defined. Okay, so I'm going to use my surfaces command here and go to extrusion. Okay. You'll find that a lot of these advanced modeling techniques here, I'm using the surfaces command. SolidWorks is actually just surfaces in the background. Well, not just surfaces, but it is surfacing in the background. Okay, so a lot of times if you can break things down into surface extrusions or surface commands in some nature, then you can get a lot of different types of things modeled that you wouldn't otherwise be able to model, with just solid geometry. Okay, so here's the ellipse. Okay, and as we all know, the first thing that you need for a helix is you need a base circle or something to set the diameter. And it's important in this case that when we go to sketch our base circle here, that we just don't go bigger than our ellipse. It doesn't much matter at this point how big your circle is, just so that it's smaller than the minor diameter of your ellipse, and that'll do just fine. So in our case here, we'll just go 45. Okay, and get my task pane out of the way here. So okay, and then we'll use that base circle, come over here to the curves command, hit the pull down here, and we'll say helix and spiral. That's where it's located. And in this case here, I've made the height of my ellipse 150 millimeters. We're going to go height and revolution. As you can see over here on the left, it is 150 millimeters tall. I'm going to kick it up to say 6 revolutions. Starting it at 0 degrees, which we know to be on the right plane, counterclockwise. Okay. So there's our helix. All right, at this point, I need to somehow get this helix projected onto my ellipse. Okay? And that's where the surface sweep comes in handy. Okay? So what I'm going to do is I'm going to start a sketch over here on the right plane. With my S key. I'm just going to draw a line. Now strategically, mind you, I'm drawing this line to where it's horizontal to that sketch origin. Then I'm going to come out here. I'm going to make sure that this is a horizontal line that I'm sketching. Okay? Doesn't really matter the length as long as it has enough length that when we sweep this profile along our helix path that it intersects the ellipse at all times. Okay. Now, another trick to this trade here is you want the relation between the profile path, or pardon me, between the profile and the path to be a Pierce relation. Okay. So what I'm going to do is I'm going to click the end point of my line, and then I'm going to control select my 3D curve here, my helix. Okay. I'm not selecting the end point of my helix. I'm selecting the actual helix curve itself, and then as I do that, I can then make the Pierce relation. The Pierce relation is a 3D relationship. A lot of times people will go back and try to use coincident. Well, one of the things that you need to think of is when you're extruding or you're sweeping or lofting or something out in 3D space, okay, your 2D profile needs to be solved for every little integral along the path. And sometimes things like horizontals, verticals, and coincidence can only be solved in 2D space. So keep in mind when you're doing a sweep or a loft and you're going along a 3D curve that you want a Pierce relation there rather than a coincident or some other 2D style relation. Parallels and perpendiculars and things of that nature are better within your 2D profile sketches. Okay. So coming up here to my surfaces toolbar, I'm going to do a sweep surface, using my line now as my profile. And we're going to use the curve, 3D curve as our path. And you can see that that gives us a nice helical sweep along there. And where these two surfaces intersect is where I'm going to get my curve from. So I'm going to come back up here. I'm going to go to Tools. Now this is kind of an interesting tool. As you go to Tools and then Sketch Tools, this is one of the very few sketch commands that you can invoke without actually being within the sketch environment. Okay? So Tools, Sketch Tools, and then Intersection Curve. And what it's looking for are, you guessed it, the faces or the surface bodies that intersect here. Okay? And that will give you your helical path along your ellipse. Let's go ahead and hide this surface here. And there you go. One of the things that you can do, you don't typically have to, but you can make this into a comp curve. In our case here in a presentation, it's easier to see a little bit if I were to actually turn that into a comp curve, right? But one of the things that you can do from here, say we're going to turn this into a spring, is I would make myself a plane. So I'm going to go to Features, Reference Geometry, and then Plane. Okay, and I would click my curve and then click the endpoint of my curve, and that will actually make a plane that is normal to my curve at the endpoint. Okay, which is the way it's utilizing the plane command over here in the Property Manager. Then of course we're free to start a sketch. Okay, on that plane, we'll grab our circle tool. Make sure that it starts there at our path. Give it a quick dimension. Maybe 5 millimeters would be good. Exit our sketch, Features, do a sweep, using that sketch as our profile, and then we come in here with our 3D sketch, essentially. Oops. Better choose my path over here. And then you end up with your elliptical spring. Alright, just check on the presentation here, make sure the screen's catching up. I see that a couple more have joined us. Welcome, gentlemen. Appreciate your attendance. We have 19 now, so that's pretty awesome. Okay.